here. Okay, so we're on page 55, lesson 6. So exponential math. So what you're going to learn here today is, I mean, you probably touched on this in algebra, but like if anyone goes into science, chemistry, finance, or banking, this stuff is very powerful and very useful. You know, for example, if you're interested in money, this is probably something you want to learn about a little bit, okay? So let's start with some simple modeling. We know about growth and decay exponentially, right? Right? So our original model was just like, the simple one was just A, y equals A times B to the X, right? And when B was greater than 0, you had growth, right? And then when it was between, like a fraction between 0 and 1, what'd you have? Decay, right? Okay. So if we go down here to this first little formula they give us, I'm going to change some of the lettering they use here because it's not quite as common. They're using quantity Q. I prefer to use amount. So let me just rewrite this. So some amount as a function of t time is going to be equal to some A naught, right? That little subscript 0, that's right, A naught, which just means the beginning amount, okay? Like what you start with, times 1 plus some growth rate, right? You'll get a percentage growth or decay, right? And then t for time will be up in the exponent, okay? Now the important thing is when you put that growth rate in there, that you have to write the percentage as a decimal. So hopefully you guys know how to convert, like if you have, 5%, you move the decimal 2 to the left and you have to use 0.05, right, for the R, okay? And so this say Q naught, so we'll say A naught is one I prefer to use, represents the amount of Q at time equals 0, right? Okay, starting amount, whatever it is. Also known as the initial quantity, time equals 0. This would be the initial quantity or amount. Okay. And if you've looked at compound interest before, this is the basis of it. But the way they have this formula written, it's just annual compounding, like just once a year, if we're talking about money with this formula. Annual compounding, not, monthly or weekly or quarterly. We'll get to that formula later with the change in it. Okay. So let's look at an example here, right? So we know we've got the amount you start with. This is the rate, percent rate as a decimal, that something's growing over time. And the exponent is the amount of time that has passed. Usually it's in years, but if you read the problem, it could be weeks or months or whatever. So let's look at the first example. Which of the following gives the savings S, so now we're going to switch to S, in an account if $250 was invested at a rate of 3% per year, okay? So which one of these is the A naught in this problem? What's the initial amount?
250.
So we have our A naught is $250, right? And what is the rate of growth?
3%.
It's 3%, but we can't use that number 3 like that. We have to convert that to a decimal, right? Percent is out of 100. How many zeros are in 100?
2.
2, right? So when you divide by 100, you move the decimal 2 to the left, and you'd have 0.03, okay? This is important. You cannot just use 3. And some kids will mistakenly use 0.3. It's you have to move it twice to the left. Everybody got that? Okay? So let's plug in to our formula up top, right? They're using S instead of A of T, right? So S would equal, what's our A naught? 250 times 1 plus 0.03, right? to the T. But we can simplify in the parentheses pretty easily here, can't we? You need your calculator. 250, what would that become in the parentheses? When you add those, come on.
1.03.
Yeah, simple enough, right? To the T. And that would represent how much money you have in that savings account over time, right? Which is choice what? What is that? Choice number 2? Yeah. Okay. Choice 2. Interest is a great thing. People give you money for you doing nothing, right? And if somebody asks, I could explain to you why they do that, and if anybody's interested, I do teach a financial algebra class. You have to pass this course first to get into it as a prerequisite. But if you're interested in money, there is a financial algebra class. Some of your juniors may be interested in that next year. But anyway, so that was growth, right, up top. Right? We just note that this is growth. Why would it be growth, right? Because of this would be the B part, right, in our original formula. And 1 plus anything is going to be greater than 1, wouldn't it? So that would make that growth. So now let's look at decay. If your money's doing this, you better go back and rethink how you invest your money. But anyway, so here's decay. Notice the difference in the two formulas. What's the difference?
The minus sign.
Yeah, so now it's 1 minus some decimal percentage rate, right? Which will ensure that this quantity here is between 0 and 1, right? If like that 0.03 we had there before, if now we did like 1 minus 0.03, will we now have some base between 0 and 1 and make it decay? Okay, but again, I kind of prefer, A of t equals A naught times 1 minus R to the t, okay, R being the growth rate. Okay, so this would be the decay model. The growth would be 1 plus some rate, and decay is 1 minus some rate. Should be simple enough, right? So let's look at exercise 2. If the population of a town is decreasing, what does that word tell you about which formula we're going to use?
That's decay.
That is decay by 4%. Here's our decay rate. What would that be as a decimal, that 4%?
0.04.
0.04, right?
0.04.
Right, yeah. Because you got to move it twice, right? Per year. And they started with 12,500 residents. That sounds like A naught, right? So we have an R for a formula of 0.04. We have an A naught, an initial amount of residents at 12,500. Okay? And we need to write an exponential decay model and figure out how many people are in this town in 10 years. So T equals 10, right? So what's our model? So it would be A of T would be our initial amount times 1 minus 0.04 to the T, right? And in the middle here, let's simplify that. So A of T, in the parentheses there, 12,500. What's that going to be in the parentheses, guys? What's 1 minus 0.04?
0.96.
0.96. Hey, that's between 0 and 1, right? So you can see that's going to have to be decay. All right, so now we're going to do A of what? Now that we have our formula, we're going to do A of what?
A of 10.
All right, so let's do that. A of 10 going to equal this 12,500 times 0.96 to the 10th power. And this, might talk about number sense aside. You're probably going to want to use your calculator for this, right? You punch it in there. I'll show you let me bring this one up. Make it bigger. Can everybody see the calculator I brought up?
Yeah.
Okay. So, do you see this home button here? Didn't do anything. Why is it not doing it? There we go. So you hit that home button. It looks like a house, right? So I want to make a calculation. So clear, you can see I'm going to arrow over to calculation. It's not quite, there we go. And hit OK. And so now down here in the bottom, I can start typing in what we had there. So I'll do 12,000. Why does it not want to? Okay. Not being very sensitive. Parentheses, 0.96, close the parentheses, right? And there's no caret button on this, right? But it's this X to the Y button. Everybody see that? 10. Okay? And then hit OK. So how much money, or yeah, it's not money. How many people are in this town?
8,310.
Right.
300
Are we gonna call it 0.408?
no,
I don't really want to
Not
run
the
into, I don't want to run into that guy. All right? He's probably a guy, I don't know, he's got no legs, no arms, probably riding around on a skateboard. And that would be very disturbing, right? Anyway, so let's go back here. And I just lost it. 8,310, right? So A of 10 equals 8,310 people. All right, does anybody have any questions on that? Choice 4. And again, like when you see this on your homework, even with multiple choice, right, this is the work I need you to show, okay? Does anyone have any questions on exercise 1 or 2? How to plug things in, how to convert from percent to a decimal. We good with that? Okay. Now here's one about stocks, which in that other class I teach, we get into pretty heavily, actually, analyzing stocks and stock prices and evaluating companies and whatnot. But anyway, so the stock price. Do you guys know what a stock is, by the way?
the basically how valuable the company is.
Well, the dollar value of the stock is, but a stock in a company, if you purchase what's called a stock in a corporation, you have purchased partial ownership of that corporation. You now own some percentage of that corporation. I don't know if you guys knew that or not. Right? And so then you are entitled to any gains or losses that the value of that stock, the company has as they move along. Okay? Anyway, so stock price of this Wind Power Inc. increasing at a rate of 4% per week. Its initial value was $20, okay, per share. And now we have another stock, okay? So now we got this company stock, and now we have this, what is it, Gerbil Energy? Good. Is losing value. So the other stock is going to be decay, right? The first one will be growth, the other one will be decay. And it's decaying at 11% per week. Okay? It's losing value at 11% per week. Its initial price was 120, right? When the other one was 20. So what they want to know is after how many weeks will the two stock prices be equal, be the same? So there's a bunch of ways we could do this. I think we should probably start out by writing an exponential model for both, okay? And then graph them. And we can use our graphing calculator. And if we graph these two functions that we're about to write, where will we find where they're equal? Will the two graphs do what?
Intersect.
Intersect, right? You've done that in algebra, right? With your fancy yellow calculators there. Well, let's write an exponential formula for wind power, and let's use some letters that make sense. How about we use W of T for the wind power company? Okay. So what was its initial value?
Initial value was 20.
$20, right? Times 1 what?
Plus
Well, I'm just going to add them now. 1 point what?
1.04.
0.04, right? Because the R is 0.04 if it's 4%, right? To the T. Everybody with me there? And now maybe for the other function, it'll be G for gerbil, right? So G of T for the other stock, we're modeling it like this. What was its initial value?
120.
120. And now it's not going to be 1 plus, it's going to be what?
1 minus.
1 minus 0.11. What is 1 minus 0.11?
Um, 0.89.
0.89 to the T. So is 0.89 between 0 and 1?
Yeah.
Yeah, so clearly it's got to be decay, and the other one is greater than 1, so clearly it has to be growth, okay? Well, we'll make a rough sketch of the graph here, but then we're going to do it on the calculator. So let me just draw an axis. It's probably going to be kind of like this, roughly. I don't know exactly yet. We'll figure out, right? So this axis up here, what would normally be the Y, we'll just call that dollar bills, dollar value, right? And the bottom, what would normally be the X-axis would be what in our case?
The time.
T, right? That's our input. So we're inputting time, right? And dollar value will be the output. Okay. So if you guys have your calculators on your screen, maybe you can follow along with me on this one. So let's go to that calculator. All right. So I want to get to where functions are. So I'll hit the home button. I'll hit the home button. It's not doing, there we go. Arrow over the functions and hit OK. I've got one of those from earlier, right? Now, if somebody gets lost as I'm doing this, let me know, all right?
My calculator won't even let me turn on. I'm clicking the on button and it's not working.
Does it even have like where it shows the buttons and stuff?
Yeah.
Yeah. Well, try that. This works sometimes. Let me pause the recording. Keep recording. All right. So now that we've entered those, I want to arrow up to where it says graph. So I'm going to arrow up and then go over to graph and hit OK. And we're going to have to adjust our axes here. This is different now. Okay. This is totally different than the way it looked this morning. I wonder if it updated itself. So let me go. You can't see the graph here because we're on a really small axis. Escape down to. Okay, well, that was definitely different. Escape. Functions down to auto. Navigate axis. This is different. No, I don't like this. This is not doing the same thing it did before. Let me try this EXE key at the bottom. No, back. It is just not doing the thing that I wanted to do. Auto. Okay, well, auto's a little bit better. It did have a way to go in and like put your X min and X max in there. I can't find that right now. And that is puzzling me. You hit the EXE button again. Calculate, not go to, what does that do? No. Oh, the stupid thing. Let me take it off auto again. Escape. Up, down. Let me navigate axis. So probably if I zoom out now. Okay, that's a little better. That is not how, I mean, just right before this class, I had this thing where you could set the X and Y min and max. But anyway, hopefully you got something like this. You can see the two graphs intersect here, right? Let's go back and just make a rough sketch of that, right? So it looks like the number of weeks where they intersect is somewhere around 12-ish, right? So maybe we'll make our time axis out to 15, and then maybe we'll make our money axis maybe to 130. So let's just roughly go back here. Whoopsie daisy. There we go. So let's go out to 15 on the time axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's 15 counting by ones. And I don't know, maybe we'll count by 20s over here. 20, 40, 60, 80, 100, 120. Okay. 14, 13. So 12 is look like we're about where they were going to intersect, right? So the one stock, the WFT, didn't that start up here at 120? Right? And it's decaying down like this. Okay. And what value did the other stock start at?
It started at 20.
At 20. Maybe I'll use a different color here. So that started at 20, and that's slowly growing. That is way off. Let me just like that. I don't know, like that, right? And I will tell you, this is a really rough sketch of the graph anyway, right? So we'll call this one, this is our W of T. And then the other one was what, our G of T, right? Okay, so let's figure out exactly where that intersection point. Remember, T is time in weeks, right? So let's go back to our calculator. And now down on the very bottom right button says EXE, execute, or whatever. I'm going to hit that. Yeah. Okay. Yeah. What if I hit escape? And I'm going to hit, okay. And now I want to calculate something, right? So I'm going to hit the right arrow. Does anybody see something there that's going to be what we're looking for? Because we want to find out where the two models are equal.
Intersection.
Intersection. So let's arrow down to intersection and hit OK. Now it doesn't, it's cut off on my screen. Maybe you can see it would be all the way down at the bottom, right? For some reason it's cut off. Well, I can see it in the smaller version. Can you guys see it on yours? So that intersection is at X equals what?
11.5.
Right? And then maybe you can see it says G of X equals F of X. And what is their dollar value?
31.433.
31.43, right? We don't, so money's two decimals, right? So let's go back here. We'll mark that. So let's go back here. So this point here is the coordinates 11.5, comma, 31 point, what do we say, 43? Okay. So the 11.5 represents the number of what?
The number of times, the amount of time. How many weeks?
Weeks, right? And they both have a value of 31.43, right? What is going on with my board? $31.43. So after 11, so one stock is growing, the other one's declining, and if they continue that trend, after about 11 and a half weeks, they'll have the same value, okay? So I know that the calculator thing seems to be a little sketchy. Let me show you maybe the Windows calculator version. So if you hit your Windows Start button, some of you aren't able to get that. If you don't have it, you can just, like, as soon as you hit that start on your keyboard, just start typing calculator, C-A-L-C, right? And at this point, you might want to right-click it and pin it to your start menu, right? So here's the Windows calculator. So mine says scientific. I don't know if yours does, but these three bars here, if I click those, you see there's an option for graphic, right? And I do want to make it big, so I'm going to hit that enlarge button there, okay? Let me move the recorder out of the way. Okay? So up the top right, you can see where I can enter an expression. Everybody see that? So what was our first one? It was 20. So I'm going to go down here and type 20. And then there's parentheses, 1, 0.04, close parentheses, and there's x to the y, and then should be, and here's x, the x. That works, right? And let me hit enter. I'll put it change. So that's the first stock, right? And I think this is neat because I can just kind of drag the screen around. I don't want any negative values, right? So, whoops. Kind of do like that. And now let's put the other one in. Now I can put the other expression in there. That was 120 times 0.89 to the x. Enter. So, yeah, I'm just using the roller on my mouse, to, right? So then you can kind of trace here, right? You see where they're both, I got 11.5, 31. I wonder, it doesn't do, start tracing. Start tracing. Like that. Start tracing. I use the arrow keys on my, yeah, I could use the arrow keys on my keyboard. I don't know if that's any better or not. Get in here. All right, so now I can kind of move along one or both of those. I don't know. But, you know, you can kind of, maybe if I zoomed in, I'll get more accurate. There we go. 11.5, this is $31.40, right? And so if you're having trouble with the calculator I gave you guys, maybe this one will help you, or some other version you can find. Okay? All right. So that is that from that lesson. Does anyone have any questions? Make sure you know which model you're going to use, whether it's the growth 1 plus R or decay 1 minus R. And also, whatever percent they give you, what must you do to it to put it into the function?
You must turn into a, you must,
Well, divide it by 100, right?
yeah, you divide by 100.
Yeah, just you move the decimal 2 places to the left, okay? I hesitate to say write it as a decimal because it might give you like something that's 5.2%. It's already decimal, so then you're confused when I say write it as a decimal. So I'm going to say divide it by 100, right? Slide the decimal to the left, okay? All right, and hopefully you can navigate with the calculator on the problem set. If not, you know, let me know, figure something out. I'm kind of learning as I go here with this virtual physics too. So, okay, so we'll stop here. And what was about 20 to 9? Half an hour maybe? You want to come back at 9:10? Does that sound good, you guys?